Hello dear friends, and welcome to this video today in our YouTube channel. In today's video, friends, we shall be looking at these two integrals. That is the integral of 1 over the square root of 1 minus 4x squared dx versus the integral of 1 over the square root of 4x squared minus 1 dx. So guys, please stay tuned and watch this video from start to finish, because by the end of today, guys, you shall be able to detect if these two integrals are the same or not, because they look pretty alike, yeah, except for the mode of subtraction, because here is 1 minus 4x squared, and here is 4x squared minus 1. So guys, let's dive straight into the video, and please don't forget to subscribe to this video, guys. Don't forget to subscribe to our channel and like this video, because that does motivate me enough to keep producing more and more content. Thank you very much indeed. So let's dive straight into it, guys. Okay, so now let's look at the first one, guys. Let's look at this integral. But if you were in that examination hall, guys, which one would you integrate first? All right, great, done. Right, so would you definitely integrate this one, because it looks somewhat easier than the one we had initially, right? Good. So let's look at it. So guys, in our first step now, we are going to write it as the integral of 1 over the square root of 1 minus, we are going to write this 4x squared as 2x, all that squared. And the beauty of doing this is that we can easily do a dash, guys. Just suggest what method are we going to use? Or why am I writing this? Why am I writing 4x squared like 2x, all that squared, guys? Great, you got it right, because I'm going to do a trigonometric substitution. So guys, in this case, I'm going to let my 2x equal to my sine theta. Great, you let 2x equal to sine theta, such that if you differentiate, guys, you are going to have 2 differentiating x dx equal to differentiate sine, guys, gives you cos theta d theta. That's great. So now, guys, in this case, now we are going to divide all through by 2 to make the x the subject. We are simply going to have the x to be the same like cos theta, all that on 2 d theta. Great. So now, guys, I think we are ready to take this integral from the x world to the theta world. Right, great. That therefore means that this our original integral now, guys, is going to translate into the integral of 1 over what is our 2x, guys. It is what? Sine theta. So we have sine squared theta since it has been squared. Then what is our dx, guys? Our dx is simply cos theta over 2 d theta. That's what we have here. Great. So we replace everything, and guys, don't forget that 1 minus sine squared theta is the same like cos squared theta. Great. So we are just going to have the integral of 1 over, like I said, this input 1 minus sine squared theta is simply cos squared theta. Inside the square root, there we have this remains the same. Then now, guys, the square root and the square, they are going to cancel, so we are simply going to have the integral of 1 over cosine of theta into what we have here initially. But you see that the cos theta and the cos theta, they can cancel, right? So we have the integral now of 1/2 d theta, but the 1/2 is a constant, right? So we can put it outside of the integral, guys, to have 1/2 times the integral of 1 d theta, or just the integral of d theta, and that simply gives us theta. So we have 1/2 theta. Guys, we are done with the integration, right? So in this case now, we are just going to put our plus c. Great. So that's what we have. But guys, don't forget that this is just our answer, right? But we have to integrate with respect to x, so we have to leave from the theta world and we go back to the x world, and here is what can help us to do so. So now, guys, we should know that our 2x was the same like what? Sine theta, right? So if we make theta the subject by taking the sine inverse, we are simply going to have our theta to be the same like sine inverse, or the arc sine of 2x. So this our answer now turns out to be 1/2 times our theta, which is sine inverse of 2x now plus c. Great. So guys, this is the answer in which we have. So guys, let's please don't forget to like this video, guys. Just press the like button beneath this video. That's going to help me so much. And subscribe to the channel and share that with your friends. Thank you very much for doing so. Let's dive straight into the next, guys. Okay, good. So guys, we are now going to be looking at now the integral of 1 other than 4x other than the square root of 4x squared minus 1 dx. So guys, like we did initially, we are going to do a trig sub but a different trig sub. So we are going to write this guy as the integral of the square of 1 over the square root of, we'll see this 4x squared to be the same like 2x all that squared minus 1. In this case, guys, we are going to do a trig sub. But what is that trig sub we are going to use? We are going to use now was secant. We are going to use secant. So in this case, guys, we are going to let our 2x equal to secant of theta. That therefore implies if we differentiate, guys, we are going to have 2 dx to be the same like differentiating sec theta, guys. That also gives us what? Sec theta tan theta d theta, right? So now if we replace everything now in this our original integral, we are simply going to have the integral of, keep in mind that our 2x is the same like what? Sec theta. So we are going to have the integral of 1 over square root of sec squared theta minus 1. Then what is our dx, guys? If we divide all through by 2, we are going to have our dx to be sec theta tan theta on 2 d theta. Great. And guys, don't forget that sec squared theta minus 1 is the same like what? Tan squared theta. And tan squared theta in a square root simply gives us tan theta. Great. So this is what we have, guys. And the tan theta can cancel with the 1 up. Great. That therefore implies we are now going to have, and we keep the 1/2 outside, we are going to have 1/2 times the integral of just sec theta d theta. Great, guys. And I have a video on it, guys. I have a video on how I integrated sec theta d theta. So guys, if you have not watched that video, kindly go and check it. I'll put the link to that video in the description for your convenience, guys, so you just check it. In this case, I'll just state what the answer should be. So this is going to be 1/2 times the natural log of the absolute value of, we have sec theta plus tan theta. Great. And we're done with the integral, so we just end up with our plus c. So guys, I solved this guy twice. Okay, I solved it twice, of which I used 2 different methods and I got 2 different answers, which all the 2 answers are correct. But when you differentiate, they might be off by constant. So you might choose the other version that involves the half angle identity to use. You are still going to be perfectly correct. Good. The normal deal, guys, we have to leave from the theta world back to the x world. Oh, great. So in this case now, let's not forget, guys, that that our 2x is the same like what? Sec theta. That therefore implies sec theta is the same like what, guys? 1 over cosine of theta. Implies we are going to have our 2x over 1. We are going to divide by 1, which is the same like this. So if we invert both sides to solve for cos x, we are going to have our cos x will be the same like 1 over 2x. So guys, we can now draw our right triangle of this form. We can now bring for the right angle triangle, and we can put the angle at this point to be theta. Then now we know that cosine is what? Adjacent on hypotenuse, right? So this is going to be the adjacent. We are going to have it as 1. Then the hypotenuse, we are going to have it as 2x. Good. Then now to figure out what must be here, now we are simply going to use Pythagoras theorem. That is the square root of 2x squared minus 1 squared, of which we are simply going to have the square root of 4x squared minus 1. Good. So in this case now, guys, we can evaluate what is tan theta. We can use that tan theta in this case. Tangent is what, guys? Opposite over adjacent. Opposite on adjacent. So this is going to be the opposite, which we have here. Adjacent is 1. So we simply have just what we have at the top unchanged. So guys, now this our answer now turns out to be, now if we replace everything, guys, we are going to have 1/2 times the natural log of what is sec theta, guys. We have here to be what? 2x. Then plus tan theta is what I have here. Great. So this is what we have, guys, as usual, plus c. Great, guys. You can see that the 2 answers are completely different, right? They are totally different answers, totally different. So guys, is to tell you that these 2 integrals are not the same. Okay, they are not the same. So thank you guys for watching the video, and please don't forget to like this video, share with your friends, and most importantly, guys, subscribe to the channel and press the notification icon so that you get notified each time we have videos, because we upload videos every day, guys, every day, and you can afford to miss. So kindly subscribe. Thank you for watching.